Alright, so there is our warm-up. We talked about the difference between arithmetic and geometric. One has a common difference, one has a common ratio. We talked about the difference between a sequence and a series. Sequence is a progression, and a series, you're adding up the sequence, okay? Alright, now let's go to our lesson for today, which is we're going to talk about evaluating both finite and infinite geometric series. So remember, series means what are we doing? Add them up, add them up. And here's where it's interesting. Finite makes sense. Can you add up an infinite geometric series? Oh, we'll just let that stew for a second, okay? Alright. Let's zoom in right here on your notes. When I'm looking at this formula right here, this is going to be the formula for a finite geometric sequence. If we're summing it, in other words, if it's a series, okay, it's going to be this guy. Where what does a sub 1 stand for? And then r is? Okay, I'm going to add that over here to our board for our list of formulas we need. So I get a sub 1, 1 minus r to the n, over 1 minus r. By the way, you need a calculator. If you don't have one, go get one. Now, some of these you can check just by adding them up on your calculator. But what we're going to do is talk about how you can also use the formulas to do this to double check your work and make sure we're good. In the meantime, camera's rolling, let's tell some jokes. Why do none of the sea animals like the lobster? He's so shocking. Get it? Why do none of the vegetables like the peppers? Because they get jalapeno face. Okay, last one. You probably know this one. What do you call a fake noodle? Impasta. It's a great one.
You told that joke during the COVID testing.
Yeah, and you were probably the only one there. So.
No, I heard it.
You heard it too?
Yeah, I was sitting there, I was like, oh goodness.
I did, yeah, I was just cracking jokes. That was like my favorite testing ever. They gave me a microphone. I'm like, whose idea was this?
Yeah.
I came too early.
Yeah, same.
Alright. Okay, here we go. So, if I'm doing the sum of the geometric sequence, in other words, a series, that's the sum, could you just go on your calculator and just add all those up? Yes, but that's not the point. Because we're going to do the ones, we're going to have ones that go on for long periods of time that you can't just add up. So we're going to practice with these shorter ones. I will get to them. Thank you. So, let's use our formula, okay? So, in our formula, we've got... Oh, let's not use that one. A sub 1, 1 minus r to the n, over 1 minus r, right? That's our formula. So when I'm looking at this, do I know what the first term is? That's pretty obvious, it's just negative 1. How many terms are there? So that's easy, right? Now, the one that might take a little bit of thinking is, what is a common ratio? What are we multiplying by to get from the first term to the second to the third to the fourth? And it's going to be 6, right? I times by 6, times by 6, for each of those. Alright, so the ratio is 6, n is 5, and a sub 1 is negative 1. So I'm going to plug all of that into my formula over here. Negative 1, 1 minus 6 to the 5th, divided by 1 minus 6. Now you have to be careful with your parentheses when you put that in your calculator. But now let's have everyone go on their calculator, boop, 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 plug that in. And once you have it, then let's also just try to add it up the old school way. just add it up this way, do you get the same thing? Need some time here to do that. Okay, what did you get when you used the formula, plugging it into your calculator? Someone have that yet? Allie, what'd you get? Can someone agree or... Cool, so I got some people saying yep. Alright, now the other thing is, what if we just added up plain old-fashioned way? Do you get the same thing? Okay, so cool. With these shorter ones, you can just add it up by hand, but we want to practice doing this with the smaller ones before we move on to the bigger ones, okay? So let's now move down to these ones. Okay, number 4, what I want you to do is I want you to turn to your neighbor and figure out what's the first term. That should be easy. What is a common ratio? It already tells you that n is 9, so the main thing is just what is your ratio, okay? Talk to your neighbor, go. Alright, Brandon, what did you say?
2.
You guys agree with 2? We start with -4, and then we're just going to times by 2. How many times do we do that? 9 times. So, if I'm using my formula, I'm going to do -4 times the quantity, 1 minus 2 to the 9th, over the quantity, 1 minus 2. Does that look right? Using our formula over here. Cool, so then I go into my calculator, careful with my parentheses, plug in all that in. Alright, what'd you get when you plugged that in? 2044. Are we in agreement? Nice, so see, this is kind of a cool way. Could I have gone through and done -4 plus -8 plus -16 plus -32 and then just kept doubling, so then I would have thought -64, -128, -256, -912, 512, -1024, and just added all those up? Yeah, but then I could have miscounted, or I could have made a little mistake, so I think this is our better way. Okay, now let's go to number 5 here. This is one that Hiram called the weird E. What is this called? It's called sigma. Good job. It's a Greek letter, sigma, and it stands for sum. Good job. So we add it up. Now, this is your lower limit. This is your upper limit. All you do is you plug in the number, and then it will tell you what's there, and then you can add that up. However, is there maybe an easier way we could do this? Could we use this formula? Sure. When I look at this formula, I just need to know what is my first term, what is my common ratio, and what is the number of terms. I use n, they use k here. Does that matter? What is the number of terms? How many? We're starting at 1, and then we're ending at 9, so what is n? 9, okay? Now, to get the first term, what are we just going to plug in? 1, and when I plug in 1, I get that this is k to, that becomes 0. What's -5 to 0? Don't say 0. 2 times 1 is 2, so my first term is 2. Okay, so when you're looking at this, that 2, that is your initial value, okay? This should remind you a little bit about when we were doing exponentials. And we said an exponential can be a times b to the x, where the a is a y-intercept, the initial value, and b is what you're multiplying by each time. Well, in this case, what is our common ratio going to be? What are you multiplying by each time? It's the -5. If you look at your formula for geometric, this looks like the explicit formula for geometric, right? Where A is your first term and R is your common ratio. So R is just -5. So if I want to use that same formula, we're going to do my first term, which is 2, times a quantity 1 minus, but notice here our ratio is negative, and I've got to put that in parentheses, -5, and we're going to raise that to n, which is 9. And then on the bottom we have 1 minus -5, just like that. So this one is a little trickier just because of the negatives, but as long as you do your parentheses right, we should be okay. So let's all plug that in, and then I'll show you a cooler way to check that. Okay, did you plug that in? And what did you get, Peyton? Like that? You guys agree with that? Cool, let me show you how we're going to check that on our calculator. Do you know how to get to this? How to do sigma notation on your calculator? I taught you on Friday. Math, up. So do math, then up 3 times, and it says summation, and it has that little sigma. And then on the bottom, so if you do that, did everyone do math, up, push enter? Okay, it's going to start you at the bottom where you need to put in a variable. What are you going to put first? And we're just going to do x. You can actually do different, that's why I do x. And we're going to start at 1, so x equals 1. And then I go to the top and put in a 9. And then right here, we're going to put this, except instead of k, we're going to put an x. So 2 times parentheses -5 raised to the x minus 1. And do we get the same 651,042? Sure, you should. Do you?
Yeah. Sure.
651,042. Okay, let me walk around real quick and check. If you have questions, call me over or turn to a neighbor. If you have a question, you're looking at me like, oh no. So we're going to go to Stat Wizards on Stat Library.
I think it's the longest sentence. It's in degree. Is it supposed to be in radian?
No, it's supposed to be in degrees.
However you want.
Cool. Okay, I want you guys to do number 6 on your own. Go.
That's I forgot what the question is.
Alright, Izzy, will you tell me how you did this one, please? Well, tell me how to write that out. Like that? Cool. When you guys plug that in, what did you get?
Negative 513. Same. I got 513.
Alright, we're having a debate.
No,
We get
negative
2
5.
answers here.
Negative 513. Let's add a few more numbers now. 600, 650. You should have that one.
Is that good? How many people are getting negative 513? How many are getting the other one?
I think it's 513.
Now you got something different? Okay, let's check this using sigma notation. This is actually good practice. If we were to plug this in, we would start with x equaling 1, and what would we go up to? 9, okay. Our first term is negative 3. And we're going to times that by a ratio, which is negative 2. But we're going to raise that to the n minus 1. So why don't we practice using this? Do math, up, plug it in like this, because this is just this series, this sequence, but written in sigma notation. And let's see if we get negative 513 that way. Did you get 513? Negative 513?
I got something different than both of those answers.
I saw Peyton say it was negative 513, so we're going with it.
I got
All right.
I got
Take a second. Let me come around and look at yours and see what's going on. Maybe do this.
What did you get? I got.
I got 13.5. What is going on? This calculator sucks.
plugging it into your calculator. How are you feeling so far? Is this making a decent amount of sense? Okay. We're going to pause on that. I'm going to give you time that you can work on your homework later, and then I can answer more questions then. We have a question now? Sigma. Yes. Well, we'll be on your test. It's also called summation notation, sigma notation. Those are all good things, okay? Okay, now we're going to switch gears here a little bit and talk about what's called an infinite geometric series. In general, what do you think an infinite series does?
Never stops.
It just keeps going and going and going, right? It's like the Energizer Bunny. You guys know what the Energizer Bunny is? Yeah. Okay. Just making sure it keeps going and going and going. Now, we talked about this already. What does it mean if the series converges between if the series diverges? Why don't you turn to your neighbor and see if you can remember. What does it mean if the series converges? And what does it mean if the series diverges? Okay? Talk to your neighbor. Go.
Convergence goes like all the way up to infinity. Or no, like forever. If the divergence gets closer to something. The divergence goes down like.
Alright, let's go back together. I'm going to have Micah just say what he told Hiram really loud. Go ahead, Micah.
Converges. It's just gonna continue to infinity, and if it diverges, it's gonna get closer and closer to a number.
To something, right? Alright, so do you guys remember that? Divergence. Remember the movie Divergent? Where they're like, we want you to conform to convergent. She's like, no, I will be my own self and whatever, okay? Alright. Divergent, so if it diverges, do you think we can add it up? No, because it just gets bigger and bigger and bigger and bigger, and it goes on forever. But what's interesting is that if the series converges, meaning it gets closer and closer and closer to a number, you can add it up, even if it's infinite. Now, a lot of times people are like, you can't add up something that's infinite, Silver. Watch this, I'm going to show you something. Let's take a sequence. My first term is 0.3. My next term is 0.03. My next term is 0.003. Guess what my next term is going to be? Okay. Now this is actually a geometric series because we're dividing it by 10 each time, right? Now that's going to keep going and going and going and going and going and going. And so I'm going to put dot, dot, dot. But when I add it together, what is that going to give me? 0.333333333 forever. But what is that? Isn't that just 1/3?
Yeah.
Did we just sum up something that was infinite and represent it with something that's finite? Whoa, pretty cool, right? So now the reason why we were able to do that is because this is geometric and the ratio is less than 1. It's converging, okay? The ratio here is that we were dividing by 10, or in other words, timesing by 1/10, okay? So, big moral of the story here is that for a geometric series, if it converges, then we can add it up even if it's infinite. Now, the formula for doing that is actually relatively simple. It's easier than what we did before. And I'm trying to see where they put it on here. Maybe it's on that too. There it is. If it converges, the formula is just A over 1 minus R. That's for the sum. So let's add that over here to our list of formulas. If it's infinite, then I'm going to do A over 1 minus R.